Hello and welcome. I'm really happy to see you all here. So today we have gathered here as we have prepared a presentation, which is going to be like, I understand it as basics of Wi-Fi, but my colleagues, they believe that this is like a deep dive into Wi-Fi. We had some experience with Wi-Fi, and particularly we spent a while working with a company that was the leader in Wi-Fi surveying. I can't tell you much about that because most of that is covered by different contracts, but I'll try to share with you some learnings that we had over this long route that we spent years with them. So hopefully this will be helpful for you, and in the future you will be creating better and much more organized Wi-Fi network and Wi-Fi experience for the users that are using your networks. And also probably it's going to be an interesting story. I'll try to tell it as a story, but most of that is probably not going to be a real story. It might be an imaginary story. So today's presentation, we'll try to sneak it into like 45 minutes, and then we're going to have a presentation about our company. So let's imagine that it was like the 2000s, the early 2000s, if you can get back there. You probably recall it was like the boom of those wireless phones, the 2.4 wireless phones. They had coverage of like, I don't know, like 30 meters, and that was like the thing. Everyone was trying to have one, to get his hands on, and yeah, that was wireless phones. That was really booming through this time, and there was a company that saw an opportunity there. This frequency, it was starting to get popular. That was the Wi-Fi, the start of Wi-Fi, 2.4 Wi-Fi, and even the earlier ages before the 2.4. But let's imagine that they figured out that there is some spectrum, which is the 2.4, and it's open for everyone to broadcast whatever. So they tried to create Wi-Fi over this particular piece of the spectrum. And this company, they used the really early Wi-Fi implementations, really early routers, access points, and wireless network cards. So they decided to step on that and try to create an indoor positioning system, which is like tracking, but indoors. You know, probably there are limitations with GPS, so they tried to overcome the limitations that they had with the GPS in order to position things in closed spaces. You're probably wondering why they are interested in that, but if you imagine like an airport or something really big, like a hospital, and if there is some equipment that you're particularly interested in and you don't have enough of it, let's imagine that those are like the transporters for the aircrafts. So you're interested, where is this thing? But let's imagine that this is indoors, probably the carriers for the luggage. And you have like 20, 50, whatever amount, but there is some insufficient number. You miss like 10 of them, 15 of them. So you're interested, where are the ones that you can use in order to do your job? One of the particular examples that we received is a hospital. Let's imagine that you're using those devices for measuring blood pressure and heart rate and whatever, EKGs. So you have like 5 of them, but you have 10 specialists, and they're all interested in those devices. So they try to like overtake them. They try to conquer them and keep them in their cabinet. For a while, that worked, but then they decided that the other specialists, they have equal rights, so they also need this equipment. So they advise the doctors to bring it back. Whenever they are not using it, they will bring it back. But this didn't work because it's not really convenient for the doctors picking a device, working with it, and bringing it back so it will be cleaned and the other doctor is going to pick it up. And then they have to go again and pick another set of this device, use it for a while and bring it back. So those doctors, they were trying to keep those devices busy all the time so that they won't have to return them. And on the other side is the hospital, which is trying to give the opportunity to the other doctors to use the devices. And they decided to use Wi-Fi tags. They will have something that will be located by the access points, and they will know where those devices are. This really wasn't easy. It took years. And the difficult part of that was Wi-Fi. Wi-Fi is a living thing. Wi-Fi changes over time. Wi-Fi is not something you just set up and it works. Wi-Fi is pretty different, and not many people understand it. And in those early ages, the devices that they were using weren't great. They were using the principle of triangulation. you probably know how triangulation works. So if you have 3 access points, you can probably measure what is the projected signal range at some point, and so you know where you are in 3D space. By knowing where are the access points, you'll figure out where you are. So they decided to step on this principle, and really soon they realized that they need some sophisticated equipment in order to figure out what is wrong with the network, because sometimes it is really accurate, sometimes it's not. And that was the way that they could debug that. They needed something that is really ancient and is not really accurate. In fact, it is really accurate, but it's really hard to read. So they needed something that is a bit more digital, something that is easier to keep track, something that is easier to compare and probably plan on top of what you're seeing there. But you know, that was the early 2000s, so they didn't have much options. By using this device, the oscilloscope, they figured out that this Wi-Fi spectrum, the 2.4 bandwidth, it is split into different channels. Those are the channels that the devices use. But those channels, they are not really like tunnels. Not everyone is keeping the particular channel that they are declaring that they are using. Those channels, it appears that they are overlapping with each other. And this is really a big problem. But you know, with an oscilloscope, you can't know everything about the network. They figured out that there are issues, so they needed a bit more sophisticated equipment so that they can figure out what the issues are. But they already figured out that there are some devices that use wider channels, like 40 megahertz of channels. And that was an issue. So by then, they figured out that there are several different types of issues that they are seeing in the networks. So the first type of issue that they figured out is co-channel interference. This means that there are many devices broadcasting on the same channel. Do you know what the issue with that is? No? So Wi-Fi works like that. There is someone that keeps a token, and then this one is sending the token to someone, and it's like, hey, is there something that you want to tell? No, nothing. You? No, nothing. And then the next one, and the next one, and the next one, and then the token gets back, and then we start again from the first one. So the issue is that there is only that much time, and when you have more devices, that time is split between those devices, and at some point those devices are competing for time to talk. If there is someone that needs to send like a really big message, let's imagine that this is a torrent client or probably like YouTube or someone, then this piece of bandwidth, it takes a really long piece of time into this spectrum that you have, and then those devices are competing for time. So that was the first issue that they had to target. Let me get back. So the second one is adjacent channel. So here the problem is, you can probably recall the fascination when you were configuring your first Wi-Fi. You see some preferences, and this router, you can configure some things. And at some point, you're really interested into figuring out which is the channel that will give you advantage over the others. So the beginner user, they receive some device, they plug it in, it works, and they don't care. But now you're an intermediate user. You want to take control. You want to make it better. So you log in, and you check what are the configurations. Then you figure out that there are some applications that can give you what is at which channel, so that you can figure out which is the channel that is less occupied, so you can assign this channel to your device. But the thing is that this is not always the best that you can do for your device. It appears that if those channels are overlapping, as you saw in the previous picture that we had, when they are overlapping, it's like they're speaking different languages. So if you have a device that is at channel 4 and there is an AP for this channel 4, and those devices are talking to each other, but then next to it, into the second apartment, there is a device that is on channel 5, and it is trying to talk with its access point, and they're sharing some messages. So it appears to be noise for the other device that is at channel 4. This device at channel 5, it's talking something that the device at channel 4 doesn't understand. So this is all the time, it is noise. So it has to compete with that for the same amount of time in the spectrum. They have to figure out how to ignore each other so that they can send the messages that they have. This is not ideal. And then the next problem that they had are interferers. Those are devices that are not intended to be there, like a microwave oven, but it somehow just radiates in 2.4, and this is a really massive noise generator. So when a microwave works, there is nothing that can work on top of that. There is no one that can communicate in this channel over the microwave oven. So with this company that we worked for a while, one of the things is they had a microwave oven, but no one used it. So when we got there, we wanted to warm up some water or milk or whatever, and we tried with the microwave oven. And then at the same moment, everyone gathered around the microwave oven. It appeared that this is a debug device. They used it to generate noise in the 2.4 network, but no one really used the Wi-Fi, no one really used the microwave oven as an oven, because this is such a massive noise generator, and this is such a big radiation around them that no one really, after they saw how it looks in the spectrum, they just didn't want to use it anymore. So there are those devices like childcare camera or those wireless phones. Everyone is in the same spectrum, in the same bandwidth of 2.4, and they're trying to send their messages, and not many of them understand the others. So probably a router, it can filter out some of the noise, but like a Wi-Fi phone, it doesn't care much about the Wi-Fi networks. So those guys with this company, they needed some way in order to like dive deeper, to understand what's going on, try to figure out how to make the networks better, because they have an issue there in their hospital, and there are some things that just interfere with the networks. They have to filter that out in order to make the network more precise and to figure out the locations in a better way. So those guys, they bought one of the first Wi-Fi adapters that they could find. They figured out switches for different USB. So the issue with Wi-Fi network cards in the beginning was their massive consumption of energy. So you had to figure out a really well-powered, USB-powered splitter, and probably with some piece of external power, so that you can power more than one Wi-Fi network card, so that you can have like a better understanding about the spectrum. So it appeared that one Wi-Fi network card, it can scan like 2 channels or 3 channels in like 5 seconds or 6 seconds, 10 seconds. So one card, if it has to scan the 14 channels, it will take a while. So things will change. So those guys, they decided that probably introducing another card and then another card, and all of those cards, each of them will scan particular channel. This will give them more granular idea of what's going on in the Wi-Fi network. So this thing worked for a while. Laptops were getting better. Battery life was rising from like 15 minutes to an hour. So this thing worked. But at some point, this company, they somehow figured out that the Wi-Fi indoor positioning, this is a big business, but probably a bigger business is the Wi-Fi debugging tool itself. So they decided to spin off, start another company, and introduce a tool that will help Wi-Fi developers everywhere to make better networks. And here is like a timeline of how this worked. So in the beginning, there were some, let's say, low-grade, consumer-grade Wi-Fi cards. Those weren't really precise. There are big differences between each of them. So you can't really evaluate a network by not being able to tell that your equipment is up to standards. So then they introduced their own hardware. They had to create their own hardware, or to figure out a vendor that will create something consistent with the same chips, the same antennas that they can rely on. And once they say, hey, here we are measuring this thing, this is the standard, this is the thing that we believe is actual here. So the next time that we will come, it's going to be the valid thing, the same thing. We will measure the same thing again. So they had to have particular network cards in order to make this thing happen. And then you can see that they started to catch up on the idea. They created another set of Wi-Fi cards that were faster. And so at the end, they had this tool in 2015. Over the years, they also had those experts. Someone that will go somewhere, let's imagine this is like the case with the airport. So someone will go there, they will spend like certain days, like a week, in order to figure out what's going on with the network. So this guy will bring in the expert setup, a few network cards, then a USB splitter, then a laptop, and this thing, they need to walk with that for hours over the airport, and they're probably bringing in tons of batteries so that those Wi-Fi network cards are going to be powered through the main board, through the battery of the laptop, and the laptop is going to be alive. So you can imagine that the day of an expert is going to be something like always charging the laptop or replacing batteries of a laptop, and then in an hour they need to charge the batteries or replace the batteries, and it's always a struggle with those batteries. So those guys, this company, they decided to figure out a better way to help the experts do their work longer and be better at what they're doing. But first, they came up with few rules in the Wi-Fi industry. So the right number of APs, you probably already can figure out that if there is a problem in your network, let's imagine that you have a really strange flat, so your living room is here, then here is another room, and somewhere there is another room. So with one AP, you're probably not going to cover the whole area that you have to cover. And what people usually do, they don't configure the device that they have, they just put another one. This is an interference to all the others. And most of them don't even really care about the configuration of the first one, and then the second one, and then they don't care about channels. So it's usually a problem that whenever someone has a problem, let's imagine a warehouse. So here the coverage is low, so we'll bring in another AP. Then the coverage there is low, we'll throw another AP, and then another AP, and at some point they have plenty of APs, but those APs are competing for time, or they are noise for the others, so it didn't work much better than the first time. Then they had to figure out the proper locations, because it appeared that changing the place of an AP, let's imagine the AP is going to be here, but then if we move it there, we have a different spread of the Wi-Fi network, because there is concrete, there are walls, there is attenuation in those walls, there might be some iron somewhere. So it appeared that other objects are also moving. People, they're water. So if you have many people here, then there is some attenuation and reflection. If you have like something coming, like probably a device like this screen or something else, there is interference related to that device, or there might be some, I don't know, some reflection of that device. So they figure out that if you set up the Wi-Fi network, whenever the furniture comes, you might need to reconfigure the Wi-Fi network. Or if you're remodeling the space, like if you bring in, if this is a warehouse, you might bring in something to load the warehouse. Then the Wi-Fi network might change, something might just absorb it. And then this also was an issue. And then they had to figure out the right configurations. As I told you, having a lot of access points, if you don't set up the right channels, or if you don't set up the right thresholds for roaming, or if you don't configure the right pattern for the network, like which one depends on the other, then you have a really big issue. So they had to deal with those three particular issues, and at some point they decided to go bigger. They need to plan. First, before starting, before going somewhere and measuring, they need to plan how the network is going to look. And they came up with a really sophisticated design of a tool. As you can see here, this is a screenshot of one system that is really good at that. So what you're seeing here is a plan, a building plan, a floor plan. And on top of this floor plan, the system works like that. It figures out which are the pieces, the lines that are really walls. Those walls, then they're usually figured out by the type that they're drawn. So things like brick walls, concrete walls, those are already coming from parsing the drawing that you have. If something is wrong, then you can go and change the types of the walls, figure out the locations of the walls. You can exclude some areas that you're not interested in. As you're seeing here, this red square, which is cross-hatched. So this is an area that they're not particularly interested in. And they started creating designs, placing an AP somewhere, trying to figure out the attenuation of those walls that you have just drawn, so that you can predict how many APs you need in the design. And then when you go there, you will be much better prepared, because you know what is the antenna pattern of the AP, and then what is the attenuation of those walls that you have, so that you can bring in enough APs, or you can probably set up the configuration of those APs when you're remote. It is much cheaper working from home than going on a location and trying to figure out the issues with the network there. So those guys, they had a really good planning tool, but then After dealing with the planning tool, they figured out that they have to target a few of those issues that they have already presented. So the first one that they really needed to tackle was the adjacent channel interference. So I don't know if you're aware, I will highlight the last line, the last sentence here. You can see that in a 2.4 network, the only channels that should be used are 1, 6, and 11. Do you know why? Anyone? Yeah, you know. I see. Someone else? Take a look at this graph. You're seeing here, there is some network at channel 3, and there is some network at channel 6, and there is network at channel 9. But those are overlapping. So it will be a much better design if you use channel 1, and then you use channel 6 and channel 11, because they have gaps in between. They don't interfere, so they don't hear each other, and this is not like someone speaking in a different language. They don't have to compete with each other. They are not in the same time period, so it's like you're using your whole spectrum for your messages, and you don't care about the others. Then they figured out that if everyone is setting up their network just at channel 1, 6, and 11, those networks are going to communicate to each other, so they can wait for each other. They can exchange messages, so that Wi-Fi networks will work better if all of the networks on a floor plan are assigned those channels. They will work much better than assigning them random channels. Then they figured out that there might be a really useful and good pattern. If you imagine a floor plan and you place an access point with channel 1 here, then the next one's going to be, let's imagine, like channel 6 and then channel 11. But then you have to place another AP here. Which is that going to be? It's going to be 1 again. You're placing an access point with channel 1, then 6, then 11. But then you can imagine that all in space. Like if you have to make it two-dimensional, this is, I'm putting all the APs in a line, but if you have to make it two-dimensional, then it's going to be something like that. 1, 6, 11, probably like 1, 6, 11, and then you're mixing them so they don't hear each other, and this is a really much better pattern. Does any one of you know what is this channel 14? No? In most of the countries, the channels that are available are only 12. In some of the countries, like the States, they can use like channel 13 and channel 14, but those are usually excluded because they were believed to be left for special equipment. Then it appeared that this special equipment doesn't make much use of them. And then in some regions, this special equipment has never appeared, so they enabled those channels for the Wi-Fi networks so they can make use of them. But you can see channel 14 is like a bit useful. They have figured out that they can use channel 14 much later in the development of 2.4, when they figured out that probably you need another dimension, but let's leave that for a bit later. So this channel 14 appeared to be also useful. So if you add some networks at channel 14, you can make your pattern in such a way that they won't interfere so much. And now you can imagine in time, this was like early 2000s, and now we are advancing with time. Everyone has their wireless phone, everyone has some wireless network at home, everyone has some wireless device, and you can imagine that the spectrum, the whole bandwidth of 2.4, it was like this big. So those devices, everyone now has few devices at home, and this spectrum is limited. So we can't have many things there. So what do? We need better tools for understanding what's going on. I'll bring you back to, you are designing the floor plan. You have an idea where the access points are going to be, but until you place them there, you don't really know if it will work, because you don't know what the system, what the whole wall or the system around is comprised of, how many are the reflections. So those specialists, they figured out that if they bring this particular device, which is like, they call it an access point on a stick. So you effectively have a tripod, and you go there, you place the access point where it really belongs. So we have figured out that the best location for an access point is here. So we'll start one access point here, then the other one in the other room, then the third one in the next room. So after we power them on, we'll figure out what is the actual spread of the signal. What is the attenuation by the walls? So if we now have a good tool, we'll have a log, we'll figure out what's going on, what devices we hear at each point of the floor plan, and that's going to give us a really detailed map of how this will work. I can't give you much more details on that, but there really is a company that is really good at that, but this is just for professionals. This is not something that you can do at home. This is intended to be really high level, and it's really expensive. This particular type of work of figuring out what are the issues in a Wi-Fi network, it is really something that is well paid. So this guy, he goes there with tons of equipment, he sets this network up, and then he goes with the device that you saw with the many network cards. He goes there, does a survey, collects the data, how well he's hearing all the access points that he have placed, and then those access points are on a stick. If there is a gap somewhere, or if there is some strange antenna pattern on, or channel interference, they're easily configurable. They can set other channels, they can move them at different locations so that they can figure out where are the actual best spots for an AP. Now we are getting pro level. This is so much better. But in time, the evolution of Wi-Fi, we started from beginning of 2000s. And then you can see in the 2007 to 2013, there were so many devices coming at 2.4. Everything was at 2.4. The 2.4 got so crowded that the devices were all the time competing for time. So those networks, they were depleted. We couldn't use them anymore. And at home, you were already using your, I don't know, PlayStation, then your mobile phone, then probably some Wi-Fi TV and something else. So at the beginning, you had one Wi-Fi device. In my particular case, I was lucky to be one of the first in Bulgaria to have a Wi-Fi network card, probably like 2003. And then I had wireless network at home, and that was fascinating. Everyone was really surprised how this thing works without cables. And I just couldn't stretch cables everywhere. And then I started gathering more devices that were on the Wi-Fi. And then in the 2013, it was already too crowded. You can see that an average household has like 10 devices that are Wi-Fi powered, and they all depended in the same spectrum. So why did it become so? You probably recall this history. You probably had a Nokia at some point, then they changed a bit, then it was the infrared, we were sending ringtones and we were sending messages, and then things got a bit more interesting with the PDA devices. That was, I don't know if you recall this time, like 2005, 2006, but it was spectacular that you can have like navigation, you can have like a web browser, then probably Skype or ICQ, and you can chat with someone else that is on the other side of the globe. I was in 2007. I was in the States, so they introduced the iPhone. I was so stupid back then. I bought a PDA that was, I don't recall, HP, and I believed that that was the thing because they had open software. This is Windows, so you can put everything on and it will just work. And Apple, they introduced the iPhone. They didn't have App Store, so it was limited to just the applications that it had. And I was like, this thing is never going to work. This is an iPhone now. So everyone was trying to buy an iPhone, and this device, it is coming in the Wi-Fi network that you had, which is already too crowded. And now it's getting even more crowded. And everyone, all of your friends, when you get out, there is no internet. We weren't using that much 3G. It wasn't available back then. So everyone, when someone comes at your home and you have Wi-Fi, they're asking for your Wi-Fi key. So now even more devices are there. What is the solution to all that? That was the magical solution that we were all looking for. Do you recall when Wi-Fi 5 appeared? And do you even know what is the difference between 2.4 and 5 gigahertz? I see that you know, but you, all the others, do you know what's the difference? No? No one? So you can see here, let's see the channels. Those triangles that you're seeing here, they're really important because those triangles, those are the individual channels. So a while ago, I showed you channel 1, channel 6, and channel 11 with this width. Those are 20 megahertz channels. So those 20 megahertz channels are now represented by those triangles that you see. So you have a 20 megahertz channel at channel 36, then a channel 40, channel 48, channel 44. So you have many more channels available. This means that you have much more bandwidth, so you can have much more devices talking at the same time, and this is much better. So all those devices that you had at home, now they have media where they can send messages to each other, and they won't compete for time. And if for some reason there is a device like your, I don't know, your Wi-Fi powered TV, for instance, it can have a wider channel, which means more data can be transferred in the same time. It can use like 4 channels, it can combine them, and it can get much more of this. You can imagine it like a pipe of water. So you have a narrow pipe, and this is the amount of water that you can have, but now you have much thicker pipe. So you're receiving lots of Wi-Fi, and those devices can do much more. They can stream TV, they can have like, I don't know, at some point the video conversation started. Then at some point the messages, they became pictures. So it was getting much more interesting. You can probably recall in the early 2000s, it was so spectacular when your friends came with a 1.4 inch diskette, so that you can have like 1.4 megabytes of space, and they had everything in there, text files with links, picture of something, probably, I don't know, picture of their favorite car. Everyone had one of those, and they had their life there. So now, 1.4 megabytes, that was nothing. Bandwidth was really trying to burn by the things that we are generating. Those DSLR cameras, those digital photos, everything was getting bigger and bigger and bigger. So the Wi-Fi 5, it looked like a solution in 2014, but you know, this guy with a laptop, he's now suffering because he needed like, I don't know, like 4 network cards in order to deal with like 3 channels, or in the case 11, 12 channels. But now with the Wi-Fi 5, he has to deal with like 50 more channels. So how many network cards does he need? How much of CPU does he need in order to try to scan all of that? This didn't work. So, and also this guy had another problem. He was walking with this equipment everywhere, and you can imagine there are doors, there are obstacles, there are chairs. So this guy, he always had a problem trying to keep all the devices powered, trying to keep the battery charged, and also trying not to be hurt in the surrounding when he's walking and collecting the data. So let's imagine that there was a company that figured out that they can create another device, something that is better than all the other devices, something that really condenses all of that, those network cards, into one single device. And this will be done with a really specific hardware, such hardware that it will be the standard for Wi-Fi debugging. These network cards that they will use, they won't change with time. They will use the same vendor for the whole series of devices that they're going to produce. So this thing is going to be like the one device that goes, scans, and the data that you're collecting is actual. That is the thing that you can rely on. But when you introduce this device, there were those experts that they were already used to working with the same old network cards that they had and the USB power thing. So they didn't believe at first. When this device came, it had a battery life of like 8-9 hours. So you can imagine that we are no longer draining the battery of the laptop for charging or powering on the Wi-Fi network cards. So it was already a relief. This thing was self-powered, so it removed a piece of the burden from the laptop, but then the laptop was still there. You are carrying a laptop and walking around here trying to collect the data. So these guys, from what I recall, probably like 2015, they decided that this thing can be done with a mobile device. That was, I don't know, 2015 if you recall the time, but back then you were probably playing on your phone something like Cut the Rope or Doodle Jump or something like that. Those devices were like, I don't know, a replacement for the handheld PlayStations, but no one really believed that iPhones and iPads, those are going to be professional grade tools. But this company, they did. They figured out that an iPad or an iPhone, it has a battery life of like 9 hours. And if they're not limited by the external device, this scanner device, then they can do a full day of walking around and collecting data. Compared to the previous 2 implementations, the first one that had all the devices attached to it and powered by it, probably like battery life at best 2 hours. Then a laptop, regular laptop with a battery life of like 3 hours and a battery life of 6 more hours left into the external device. Then introducing a mobile device that's going to solve the problem. This thing will live for like 9 hours and it's going to collect the data. But the challenge is, how do we do that? You can imagine They believed back then, 2005, that these devices, they are powerful enough in order to replace a laptop. But the expert didn't believe that. It probably took something like, I don't know, 2 years, 3 years in the development. And when this company at first released their mobile solution, you can imagine now you have an expert walking with a phone or an iPad, collecting all that data. This is one-handed guy. The other device is hanging on their shoulder. So they can easily walk, navigate around, they can figure out the map, and they can figure out what they're collecting without getting stuck or hit by a chair or a table or something else. That was already a really big thing in this network and in this industry. So they revolutionized, in a way, the industry. The experts, at first, they were like, no, this is not a professional solution. But when they saw the actual potential of that, now all the experts, they're working, collecting the data on field with mobile devices, or at least most of them, like the major percentage of them, they're collecting data with mobile devices. And in 2020, or even a bit before that, there is now a popular movement. There is the expert that collects the data. When there is something happening, there is someone that can come collect the data. If you're something really big and industrial like an airport, it makes sense. But you at home, it doesn't make much sense. Or you in your small office, like, I don't know, 10 access points big office, this is not really the case of a professional coming to measure your network. So there is something that is already implemented in the newer routers and in the newer access points, which is like cloud-based debugging tool that can help the professionals figure out, are there any issues in the network that they're building? So the network, in a way, it tries to debug itself, to figure out the issues in your own network by your own devices. This is the next stage of Wi-Fi debugging, probably. It's not really well standardized, so this device that you're seeing here in the picture, it will continue its life probably for the next, I don't know, 10 years, but the next step is going to be cloud-based debugging of Wi-Fi networks. Now let me get a bit more, how to say, deeper in the knowledge. So here is the 2.4 network. You can see there, you have the channels which are 1, 6, and 11. Those are the 3 channels that you can use without interfering with anyone else, and probably without having much issues with the interferers that you just can't control, like Wi-Fi phones. Then in these 3 channels, you only have bandwidth of like 80 megahertz for the whole spectrum. That was an issue because I told you, you have many more devices coming and being plugged in, not plugged in, but joined to this network. So your bandwidth is going out, it's running away. Then we introduced the 5.0 gigahertz channels, gigahertz networks. And there you can see you have many more channels. And also you can check there are channels at different levels. So you have the narrow channels, which are 20 megahertz. Then you have a wider channel, which is 40 megahertz. Then you can have like 80 megahertz channel. And in some newer devices, you can have even 160 megahertz channel. This is massive. You can't believe. This is like gaming technology. If you really need low latency, something that is like close to real time, this is probably where you're heading. You can have 2 of those really wide channels, and you can have Wi-Fi that is really outstanding. But you know, 2 channels with that amount, we're already foreseeing that the growth of Wi-Fi networks with the pace that it's growing right now, that thing is going to be really crowded in the next few years. So another thing is coming to the horizon. This is the new thing. This is a Wi-Fi 6. Do you guys know about the Wi-Fi 6? Yeah, some of you. Okay, so Wi-Fi 6 is going to be the next thing. You can already tell there are many channels in Wi-Fi 6. You can tell here the the blue region. Those are the channels that are going to be like available for everyone, and they're, I don't know how many times, like 8 times more than the channels in 2.4. So 2.4 is already obsolete. 2.4 is now the network that only automation uses, and automation uses this network just because it's outdated. We are putting in the automation devices the cheapest AP or the cheapest Wi-Fi cards that we can have. But soon, every automation device is going to join the 5.0 network, so 2.4 is going to be obsolete. We probably won't use 2.4 in the following few years, except for those, when I call them interferers, like the microwave oven is still going to radiate in the same frequency. Probably those wireless phones, they're going to stay in the same frequency, but no one really uses Wi-Fi phones anymore. And then probably something like, I don't know, your child care camera is going to be there, but you wouldn't care because you don't have communication over there. Everything is going to be 6.0. Probably, I don't know, this is a standard that is now appearing. It is brand new. It is still in development, but at least it looks like it's going to be so big. You can tell there are many channels. There is a small comparison on top. You can see the 2.4, it's like 80 megahertz. It's like this big. And then there is the 5.0, which is 500 megahertz, which is like several times bigger. And now there is the 6.0, which is so much bigger. So probably in the next 10 years, this is the thing that's going to be the trend, 6.0. And if you manage your network in such a way that you won't interfere with different devices, like I can show you here, in the 5.0, there is this DFS channels. Do you know what it is? Yeah, you're the only one that knows. But those DFS channels, there are radars, like weather radars, or probably some military equipment, or something else, or radio stations. So those, they have a standard that they are capable and they're allowed to broadcast whatever they need in those particular frequencies. So if there is any Wi-Fi technology, it should take care of those channels and not interfere with those devices that they have higher priority. So effectively in 5.0, you're limited to those green channels. Then all the others in blue, they're used for some other purposes. And then there are some others that are left in green. So if you're using your Wi-Fi in such a way, you're limited to, I don't know, like 2 white channels or 4 white channels, and then probably like 8, 10 non-interfering channels. That is not enough for the amount of devices that we have at home already. That is too narrow. And then the newer 5.0 routers and access points, they're capable of figuring out if there is a radar or a device that broadcasts in the DFS channels. And whenever those devices are broadcasting, they'll just switch to another channel. They'll wait for a while and then get back to the channel, which they can use temporarily while no one is broadcasting. And this is really wise use of 5.0, but in 6.0, we're not even going to have those problems. So an advice that I can give you right now, if you can start planning your 6.0 network right now, you will be years ahead of the others, and you will probably be enjoying much faster internet from now for the next few years than all the others that are now trying to compete in 5.0, because at some point we're going to have that many devices that 5.0 is going to be depleted. So at some point I had a 2.4 router, and that was a massive beast. I had something with 6 antennas at home, and so we had a joke that I can boil eggs just by leaving them on the counter. So that was like, I was a maniac. I really wanted to have fast internet and fast coverage everywhere. So I needed some beast of a Wi-Fi network, 2.4. And the 2.4, it's famous for passing through walls just because of the frequency, because of the wavelength. So I was effectively abusing the networks of all my neighbors, and they weren't enjoying great Wi-Fi because of my Wi-Fi router. But at some point I figured out that I don't really enjoy much the radiation around me that much. So I switched to 5.0. And with a good configuration of the 5.0 and much better use of the channels and the white channels and beamforming, it appeared that my Wi-Fi network is so much better, even though the coverage is not that good in the areas that I don't really need my coverage to be that high. So right now our flat looks like that. There is a living room, there is the bedroom number 1, which is the master bedroom, and there is the child bedroom. Do I need Wi-Fi in the child bedroom? No, not really. I don't really care much about that. So do I really need the Wi-Fi in the master bedroom? Yeah, I can probably check the news when I'm in the bed for like 15 minutes, but I don't really care about really massive amounts of data. So the data that I really care about is the data in the living room. When I killed my 2.4 network, I figured out that my AP doesn't have the CPU time to deal with that many devices. I had 15 devices on the Wi-Fi network, and it just couldn't handle that. It was just trying to compete with them, trying to talk with them, but at some point it just gave up. So I brought the 5.0 device, which is also a beast of a device, but this thing is much different. So consider switching to 5.0, and if you can, switch to 6.0. 6.0 is coming with some benefits that we weren't foreseeing, but they are quite useful. So multi-MIMO, this is multi-input output. This means that you can remember this token. I'm giving you the token, so now you speak, then I'm getting my token back. Now I speak, then I'm giving you again the token. You have nothing else to say, then I'm giving the token to someone else, and then we're exchanging this token quite a few times. Then the multi-MIMO, it comes also in 5.0, but in 6.0, it is even better because now we have so much bandwidth that we can say, hey, we're using this white channel, but we can split it in two. So in this channel, I'm going to be sending you the data, and in this part of the channel, you're going to be sending me the data. So in the same time we are changing the data both directions, we won't need to pass the token to each other so that we can change turns in order to speak to each other. Then there is the beamforming. You can imagine that at home, you have this, let's imagine that you have some media device that is like downloading torrents, which is illegal, but okay, let's imagine that it's streaming from some source. So this device is there, and it really needs wide channel, and it really needs a lot of time. So you can have your router focus its attention on this particular device, and then figure out what the others are doing. And if there is someone else that really needs wider channel, so it can be informed to the second device and the fourth device. And now there are APs that are capable of being formed to 4 different devices at the same time. This is quite sufficient for a home. You don't have that much heavy usage at home. Then there is this bandwidth, 100 megahertz of bandwidth. This is massive. Now you can have like wider channels, you can fit so much data in them, and also you can have that many channels. So this is really beneficial. And also you have target wait time. So some devices, they can save some energy while they're waiting for messages which are not really coming at the moment. So they can like schedule, hey, for the next like 3 seconds, I won't need your attention. So I'll be switched off and then I'll come back, which is less radiation, which is also less power usage. And if you're seeing what's going on with those electric cars and solar and whatever, so saving energy in the future is going to be a bigger thing. If we really focus into like sustainable energy, we definitely have to reduce the amount of energy that we need. So this is one of the things that we can use. Coloring of traffic, this is also something important. So your AP is going to know which are the important devices, which are the devices that need attention right now, which are the devices that really need priority when they're talking, so that you can have better understanding and better knowledge of what's going on in the network. So you don't really need to know much about your refrigerator. At some point, you're going to send a message to your refrigerator. But if there is something like healthcare device, you're really interested into that. So this thing will be covered. It will be prioritized. You'll receive the data of that, and then you will deal with all the others. And you also know that the automation topic is going to be really big. In the next few years, if we had like a while ago, I had 15 devices that were in the Wi-Fi network. Right now, I have home automation, so 30 and more devices are now competing for time, some of them in 2.4, some of them in 5.0. So I have my Christmas lights, I have my refrigerator, I may have like my oven, and many, many other things are in the Wi-Fi network. So getting a better Wi-Fi network with better understanding about those devices, this is going to be really key in the following years. And also one thing, this is the last slide before we switch to the other topic. One thing about Wi-Fi networks, they have a life cycle. They just don't live for like from now to infinity, just if you leave them there. They need some maintenance, they need some understanding. Because you're moving furnitures, you may bring another wardrobe, you may bring another mirror. there might be something that changes. So the Wi-Fi network might change with that. And also, when you change the Wi-Fi network from 2.4 to 5.0, you may need some other arrangements at home. You may need some more APs, or you may need some other configuration. So Wi-Fi and checking how your Wi-Fi behaves, this is something that professionals believe is something that has to be done yearly. Each year, let's imagine the Munich airport, they have a survey each year so that they can validate that their Wi-Fi network needs are the same as the previous year, and the configuration that they had works the same way as the previous year. Because things change, and with time, you have to validate them. Now, the previous time we had a part of the whole lecture that was dedicated to our company, Droxic, but for this particular part, it is much better if we invite our HR department, because developers are only that good, but HR, they're so much better. So please welcome my colleague Eva. She's going to join me on the stage.
Thank you. So, hi everyone. I hope you can hear me well. Okay, great. I'm very happy to see you here, and that you're attending our event. And of course, I'm very grateful that I have the chance to speak in front of you and to share with you some details about the company, how did everything start, and where we're at this point. So yeah, now thanks to Dani, I will switch to the next slide.
This is thanks to Wi-Fi devices.
Yeah, actually, yeah, regarding the topic. Okay, so before starting about the information about Droxic, I would like to share with you a few words about myself. So my name is Eva. I'm part of the HR and recruitment team at Droxic, and I'm from the best city in Bulgaria. Probably you know where this photo is taken. Yeah, of course, Varna. But now, joking aside, I joined Droxic on September this year. Danny, sorry, your phone is ringing, but yeah, I think I can continue. Worries. Okay, yeah. So yeah, I joined the company on September this year. Actually, this is my 4th month, and so far I can definitely describe my career journey as a great career journey, where I have met awesome, nice, friendly people and colleagues, very empathetic, that are always there to give you a hand. So let's move now to the serious topic. Here you can see a few photos about, from the team buildings and from the conferences that we have taken part. So about the Droxic, probably you have already heard about the company, but who we are actually. Okay. Sorry about the noise. We are a top-notch digital agency that specializes in web and mobile development. The company was founded in 2012 by 3 friends who have, I think, now more than 20 years of experience in the IT field. Their names are Pavel Simov, Cvetomir Bochkov-Tropi, and Ilian Krastev. So we are a digital agency with more than 20 years of experience in the web and mobile development. Our main office is in Sofia, and 2 years ago we opened our 2nd office that is located in Niš in Serbia. The colleagues there are around 10 people. We are working for different types of clients that are in Europe and mostly in Western Europe. So as the countries here, I can give you examples: Nordic countries, UK, Germany, Netherlands. We have also clients from USA, Abu Dhabi, and many others. Due to the fact that we are working with different types of customers, we have different types of customers. Actually, we have covered so far industries like automotive industries. We have projects for medical organizations, banks, companies in the insurance sector, drought, oils, and many others. So yeah, about this, the technologies and the teams that we have, our teams are up to 10 people maximum, which give us the opportunity to work, to be more flexible and to be much more open to new technologies. Our biggest team is the front-end team. As a tech stack there, We have covered JavaScript, React, Vue.js, CSS. We have also .NET team. The colleagues there are working with different CMS systems like Sitecore, Sitefinity, Umbraco. We have the .NET Core as well, the .NET Core team as well. We have the PHP team. Here, regarding the PHP team and the tech stack, custom PHP, Magento, Laravel, Drupal, Symfony, WordPress, and the mobile team. Of course, as you are probably well aware of the fact that the tendencies and the things are rapidly changing in the IT field, we are looking for people, for developers with different types of tech stack, experience with different type of tech stack, Node.js, Python, Java. Besides these technical, oriented teams, we have QAs, UX, UI designers, project managers, HR and recruitment team, marketing, traffic department, and sales department. I can see that some of our colleagues here in the audience are actually here, so in case you have any questions about their type of work that you would like to learn more, you can ask them. Okay, and the next slide here, which is about something very important, why Droxic, and I will just show you the other pictures, and the third one. Here I'm quite sure that each of us as part of the company can give you a different type of answer, but on the listed things here that I have mentioned, I'm quite sure that we will be definitely on the same page. For us, the work-life balance is something crucial, top priority, and something very important for us, because we realize how important is the mental health and the well-being of each colleague. The individual approach is something very, very crucial for us. Currently, we're around 100 people, something like that overall. But yeah, our idea is to grow genuinely and step by step, and in order to not lose exactly this individual approach and attention to each colleague. We can definitely describe ourselves as a flat structure. There is no micromanagement. We trust each other from the beginning. Being part of Droxic also means to work from anywhere. Of course, you can visit and be part and come visiting us in our Sofia-based office, and there you will have the chance to play tennis table, which is something crucial for the office. Once you start working at the company, it's not necessary to be good at tennis, but you will have.
Helps.
We have a star here. I can see it in the audience, but later you can talk with him. You will have the chance to work on interesting and unique projects for different types of clients. We have, of course, regular team buildings and office parties. And last but not least, I can definitely describe Droxic not as your next workplace, but as your next work family, where you will be valued, appreciated, and supported by each of us. And here the next slide, and actually the last one, is about our current job openings. So we are currently on the lookout for front-end developer with Vue.js, front-end developer with React, senior Java developer, application support specialist, and technical project manager. In case you have any questions, or you would like to learn more about us as a company, more about our vacancies, or you would like to start the process with us, or of course to recommend someone, so please feel free to reach out to me or my colleagues Nat and Lori, and feel free to follow us on Instagram, LinkedIn, and Facebook. That was from my side. Thank you very much for your attention, and we will continue now with the Q&A session.
Here we have left some time. If you have any questions about Wi-Fi or about Droxic or anything that we can help, we are here to help.
In case you have questions,
Do you have any questions?
So far, no, thank you.
Thank you, Annie.
Yüksel.
No questions at all. No one cares about the Wi-Fi. That's strange. Okay, so give them the last slide and that's it.
Okay.
So here are some interesting references.
Hop.
If you're interested to know more, most of this presentation was derived from here. Most of those companies, they have, and in particular some of them, they have quite good academies for helping you with your Wi-Fi knowledge. You can get much deeper than what we covered here, but this is something that really experts need. Not really everyone needs that much knowledge. I can tell that in the audience there are people that have already reached the level that we already covered, but there is so much more to know. If you are interested in Wi-Fi, on some of those links you can find many resources. So I hope that this makes your life a bit more interesting with Wi-Fi. Thank you very much for the time.
Thank you.